Right, so today we're going to start off with writing word equations. So this is the first one. The first one is that we're going to use as an example. Aluminum bromide plus chlorine yields aluminum chloride. So to do this, you're going to need your periodic table, your polyatomic ion chart, because you're going to need to look these all up. Okay, so we're going to start by writing down the aluminum bromide. So I'm going to write down Al plus 3 and bromide, which is Br minus 1. I did my periodic table thing, plus 1, plus 2, plus 3, and then minus 3, minus 2, minus 1. I crisscross and I get aluminum bromide plus chlorine, which is diatomic. I know this because it's on my list. Yields aluminum chloride, Al plus 3, and chlorine, which is Cl minus 1. And I get aluminum chloride. Plus bromine, which is diatomic. So there we go. Now I'm going to balance this. So I see that I have 3 here and 2 here. So I know I'm going to have to go to 6. So I'm going to put a 2 here. And I'll put a 2 here because of the aluminum and the bromine. So then I'm going to put a 3 here and a 3 here, and I think that'll do it. All right, so that's the answer to that one. Notice there are no charges because everything is either a compound or an element, an atom of an element off the periodic table. There are no ions. Next, let's look at this one. So this one has calcium hydroxide and phosphoric acid. So I made our acid chart, which should be on your periodic table. If it's not, you might want to put it there. So this is naming acids, all right? And it has to do with the anions. So this is the anion here. And this is the acid. So let's take a look. First, we have calcium hydroxide. So I'm going to take Ca, which is 2 plus, off my periodic table, and OH minus. And I crisscross, so I get Ca and then OH in parentheses with the 2. Now, phosphoric acid, I look ic, acid. So that's here, ic, acid, which means it's going to be 8. So that's going to be phosphate. So I look that up. PO3, 3 minus. Oh, sorry, PO4, 3 minus. And then I add an H in front of it. Why? Because all acids start with hydrogen. So all acids, and if you need to write this down on your periodic table, it's a good idea, start with hydrogens. So then I crisscross and I get plus H3 PO4. There it is. Okay, yields calcium phosphate, Ca plus 2, 2 plus, phosphate PO4, 3 minus, crisscross, and I get Ca3, and then I put the PO4 in parentheses, 2, plus water, H2O. Okay, so now I want to balance this. So I have 3 calciums here, and then 2 HOHs, like 2 hydroxides. So I have 1 hydroxide here, and this is one of those places where I like to separate this. The reason is I can see that I have 1 hydroxide. I need 6. So I'm going to put a 6 here, and that 6 gives me 6 hydrogens, not 12 hydrogens, because 2 of them went to the hydroxides. See, the hydroxides and the hydrogens, right? So that means I'm going to put a 2 here. So that's 6 hydrogens and 2 phosphates, and now I'm balanced. Okay, so that's that. All right, so for the next part, we're going to do some work with mole equations, and we're going to use something called the Haber process for this. And the Haber process is a nice equation that chemistry teachers can use because, so N2, it has gases for all of the reactants and products. And it's reversible, which is nice because it allows us to use that in many different units. And the other thing is all of the coefficients are different. So 1, 3, 2 will balance this equation. So first, we want to notice that these are the coefficients, and they set up these molar ratios for us. So let's take a look at them. So for example, 1 mole of N2 to 3 moles of H2, or 3 moles of H2 to 2 moles of NH3. And these numbers here come from the molar ratio up here. See? 1 mole of N2 to 3 moles of H2. That's where they come from. So all I'm doing is I'm setting up like this recipe, and then I'm using this recipe to set up these ratios between the moles. So in other words, if I have 1 mole of nitrogen, I need 3 moles of hydrogen. And if I have 1 mole of nitrogen, I can produce 2 moles of ammonia. And I can do this with any of them. So I could say 3 moles of hydrogen to, I don't know what's left, 1 to 1 mole of nitrogen, which is actually the top one reversed. But I can say any of them, right? Okay. But now, can we use this for calculations? So here's an example. Okay, so here's an example. How many moles of hydrogen are needed to react with 3 moles of nitrogen? Okay, so the ratio that I'm going to be using here is between hydrogen and nitrogen. So that's right here. So we'll use this one. And I'm going to start with what I know, which is I have 3 moles of nitrogen. And what goes down? Moles of nitrogen. And I'm going to switch from nitrogen to hydrogen using the molar ratio. So for every 1 mole of nitrogen, I need 3 moles of hydrogen. So that's my ratio, 1 to 3. Canceling this out, I get 3 times 3 is 9 moles of hydrogen are needed. Okay, so let's look at another example. All right, how many moles of H2 are needed to produce 13.7 moles of ammonia if you have excess N2? So let's talk for 1 minute about excess N2. What does that mean? So that means that you will not run out of it. That's all. So if somebody in class said, do we have to pay attention to it? No, it doesn't. Let's see. It doesn't really mean you have to pay attention to it. It just means that today, and only today, we don't need to worry about the nitrogen, because by the end of this week, we're going to do problems where I'm giving you an amount of nitrogen and I'm giving you about an amount of hydrogen, and you might run out of one of them. So in that case, you're going to have to pay attention to it. But today, because you have so much of it, you have an unlimited amount, pretty much, you don't have to worry about it. Okay, so this time we are looking at ammonia and hydrogen. And so I'm going to go back up and I'm going to look at my molar ratio, which is right here, 2 moles of NH3 to 3 moles of H2. So that is my my molar ratio. Okay, so now I'm going to start with my 13.7 moles of NH3 . Okay, and for every 2, right here, 2 moles of NH3, I need 3 moles of H2. Okay, so now on my calculator, I'm going to take 13.7 times 3 and then divide that by 2. All right, so what I get is 20.55 moles, oh, that's H2. Okay, moles of H2. But I only get 3 digits, so 20.6 moles of H2. And that's my answer. All right. Now, in your homework, problem number 52, I'm letting you know, number 52, you're going to write the equation, and I don't remember what it is. You're going to write the equation between W, X, Y, and Z. I don't remember how it goes, like W plus X plus yields Y and Z plus Z. I don't remember how it goes. But then you are supposed to find the molar ratio between them, and you're given a bunch of like digits, decimal points, like, I don't know, 0.4, 1.6, 2.0, and 2.4, something like that. And you have to find the coefficients that go here. Now, the thing is, we learned when we did empirical formulas that to find a whole number ratio here, you're going to divide by the smallest number. So we're going to divide all of these, I don't know what the problem says, I don't remember, by 0.4. So if I divide by 0.4, this one becomes 1. If I divide by 0.4, this one becomes 4. If I divide by 0.4, this one becomes 5, and this one becomes 6. So now my coefficients would be 1, 4, 5, 6. All right? So that's what you're looking to do, is find your molar ratio. Okay, so now you're going to go to the homework assignment module, all right? And you're going to do the homework that is in the textbook, please. Okay, all right.